Hi, I'm Albert Bates. I'm 79 years old, and I'm coming to you from an island off the coast of Mexico, 8 miles out into the Atlantic in the Strait of Cuba. I'm glad to be here and happy to talk with you today. In 2022, the Intergovernmental Panel on Climate Change, which is a UN agency, the IPCC, issued a report on the 1.5 degree threshold, whether we're going to cross it or not, what's going to happen when we do. One of the things they said, which I thought was probably the most significant thing in the whole report, was that even if for some magical reason all humans were removed from the planet today and all fossil fuel emissions stopped immediately, all the targets you can talk about all suddenly achieved, it wouldn't matter as far as global warming goes. It would keep warming. And it would keep going on doing that decade after decade, century after century, maybe 6,000 years. We would lose ecosystems. We would have mass extinctions, including possibly ourselves. We would have terrible changes in weather and biodiversity in the oceans, and all kinds of catastrophes would happen irregardless if all the emissions stopped today. And the only thing we could do, which would really make an effect, would be to start taking carbon out of the atmosphere. To actually reverse climate change, we need to remove the legacy fossil emissions from the last couple hundred years. And to do that, there's a number of different ways that you can go about it. Now, the United Nations didn't get into this. It's commonly thought about in terms of geoengineering. There's a lot of science been done on this, a lot of engineering been done on this over the last several decades. And most of it revolves around a very expensive engineering solution called direct air capture, which is okay, except it's very expensive, uses a lot of energy, and it also produces toxic chemicals. So what are the alternatives to that? And actually, there are a lot of natural solutions that Mother Nature knows best. She's been doing for years and years and years. And my breakthrough was in 2007 when I went down to the Brazilian Amazon and I got to see a solution that was 8,000 years old, which is the Terra Preta do Indio, which is translated from Brazilian Portuguese as the dark earths of the Amazons, the dark earth of the Indians. And it's a man-made phenomenon. It actually was taking carbon from the sky, mining it from the sky, making energy, and then putting it into the ground. And the entire civilizations, the monumental civilizations of the Aztec, the Maya, the Inca, and lots of others that came and went, were built on the ability to feed massive amounts of people in a tropical area with poor soils and a lot of seasonal rain, because they had this magic ingredient, which was terra preta, or what we now call biochar. And so ever since then, since I visited there in 2009, I wrote the biochar solution. I've been working on that solution ever since. And today, I have to say, we're better positioned than ever before to actually change climate for the better. The trick is the miraculous properties of the element carbon. So carbon was formed in some distant star by some improbable reaction in physics that almost could never happen. And it comes to us by various means, arrives on our planet. Our planet is made partially of it, and all living things are based on carbon and its miraculous properties. One of those properties is its ability to transform into different things because it has allotropes, or different versions of itself. And under certain temperatures, pressures, different conditions, You can have a stalk of grass, which is carbon, a dry stalk, and that could be a diamond. Or it could be something that vulcanizes a rubber tire. Or it could be a tennis racket. Or it could be the shell of a Formula 5 race car, Formula 1 race car. It could be, and it has been, made into a snowboard for Olympic competition. And the remarkable thing about a carbon fiber based snowboard is it's superior to any snowboard ever invented before. And it's because of the remarkable properties of carbon that it can take these different shapes and forms that I began to think about biochar, which was using carbon in its fertilizer form as a plant enhancer, because it's actually not a fertilizer, it's a structure in the soil. It's like a coral reef in the soil. And it works in tandem with the biology of the soil to enhance the biology of the soil and thereby improve plant life. It's not food for plants, it's a structure. But the same properties that you can make a Formula One race car from, biochar can be made to have hundreds of different uses that could be remarkable in how fast they displace major industries that currently use fossil fuels. You can make carbon steel. You can make batteries for electric vehicles. You can make various different forms of plastics that we currently consider to be forever plastics and dangerous, and micro plastics that are going to be in the ocean forever. No, actually, you could make polymers that in the presence of ocean water unzip and become just the raw carbon and other elements again. So this suddenly opens up this vast field. And one of the areas I've been exploring the most, which I think it holds the greatest promise, is biochar as a substitute for asphalt in highways. Now think about that. You have highways that are being repaired or being poured new all over the world every year. And these highways are typically surfaced with something that is the dredges of an oil refinery. It's the black, gooey, dirty, tarry stuff that nobody could sell for anything other than the tar on a road. It's the black bitumen. And it's toxic. When the sun shines on it in the summer months, it off gases, and that air is toxic to breathe. It causes cancer and birth defects. If it rains hard on it, it leaches that toxins, those fossil fuel-based toxins, off into the surrounds, off into the verge of the highway, and then it gets into the food chain. So you're getting these toxins coming off it constantly, and you're adding every time you resurface it or patch a pothole. Well, you could do better just by using plant material that's been pyrolyzed and made into biochar and then made into bioasphalt. And it turns out that that's a superior product. In some cases, it can self-heal its own cracks. It lasts longer, costs less, and can be renewed every year from plants like bamboo that are easy and fast to grow. And you could have every county growing its own highways and producing its own bitumen on the road surfaces that way. Well, how much is that? We're talking in terms of hundreds of millions of tons of that every year. So you start to do the math and you figure out legacy carbon in the atmosphere, going back to the start of fossil fuels and what's still up there, what's going to be up there for thousands of years. There's about 3 trillion tons in the atmosphere. You have to double that, because when it goes out of the atmosphere, most of it goes into the ocean. And what happens is the ocean creates a kind of an equilibrium. It won't absorb more than it can handle. So it stays in kind of equilibrium with the atmosphere. And when you start to take carbon from the atmosphere, the ocean gives it back. So instead of looking at 3 trillion tons removal, we really start to think about 5-6 trillion tons is what needs to be taken out of the process, out of the cycle, and put into hard form, mineral form, the same way it was when it was fossil fuels. Before it was fossil fuels, it was deep underground, a mile underground. And that's the kind of long duration carbon that we really require on this planet at this point in time, not the labile carbon that goes up into the atmosphere and comes around and around in plants every year. So we take it from its plant form, which is the cycling form, and we put it into a mineral form, which is biochar, and that can be in an asphalt highway. It could be concrete in a building. It could be in a bridge or an overpass. It might be a carbon fiber wrap that goes around the columns of a bridge or an overpass. When you have earthquakes, the carbon fiber wrap keeps that column intact. That's the sort of long-term duration materials in our built environment that we need to be thinking about. Porous pavers for streets, so the rain filters through. And those can be made of biochar. Any number of products, and it may have taken hundreds of years for these products initially to be developed from fossil fuels or other sources, and now we're going to be doing that in a matter of decades. And so that's actually a huge opportunity for entrepreneurs, new business startups, general economy of countries to be able to shift into the carbon circular economy, which is the future of this century and centuries going forward.